Hello everyone, hope everybody's doing well. Since the last video, which was yesterday, um, I've accumulated like over 200 new subscribers and been getting a lot more comments and thumbs up, and thank you so much. It's really it's really growing fast, and I appreciate every one of y'all. But this video here is I'm just going to show you. I'm kind of you know, it's one of these things that when I have these prints available on my Patreon, I want to make sure that the supplies that go into this animatronic is going to be available, you know, to y'all, like servos. And I'm doing two different versions of this, and what I'm doing is I'm replacing these servos here with these other servos, and these are uh, cheaper servos and they're available, but I just want to make sure that everything, all the supplies on building this animatronic is going to be available. So let's get started. I just basically just replaced the servo sockets with the horizontal tab screw points. That way, instead of screwing down, they screw, you know, sideways. And it's a standard looking servo because most people don't really realize that wing servos exist. But, they're pretty neat servo, but um, just finding them small is on the rare. There's not too many available that small. And the whole reason why I'm doing this animatronic is mainly is to put skin on it and realistic movement, but for me to put skin on it, we have to have it to fit a resin printer the whole bust size of the alien creature that we're designing. And I and it has to fit into the printer so I can print that, and then we're going to mold that sculpture or that head bust so we can produce the skin. But here on this servo here, uh, now I just laid this servo in place. The original wing servo, when I first started designing it, I started with the eyelids and the eyeball, and I worked, from there. But it was on a flat plane when I first designed the eyelids, and when I rotated it with that wing servo. But here I'm just laying it there in place because, the servo is just a part. It's not going to be printed, but it's going to be at the right angle that I can see to where this servo will move the linkage is correct to move the eyelids. But mainly it's just to get all the servo sockets in the right position. Now these servos here did have a servo socket that I had previously already designed, but I went ahead and just started just designing it straight off just to replace it. That way I wouldn't have any, off, I guess not square to the tilt position it was already in. So I just decided just to go ahead and just design it from here. But like on this the scaffold, I just removed the screw points and just squared everything off, and then just adjusted and made these little posts, I'll call them, and they just come straight up, and then so I can put screw points there. And then I have to also look and see at a profile view to where I got to make sure that I can get the screwdriver to go that direction, so I'll have you know access point to that screw. And but it was quite simple to do. Like I said earlier, it was only 2 hours of work that just to replace all 8 servo sockets. But I just wanted to show you, and it was pretty quick and easy. But I've not got a final design yet because I want it's getting close because I guess I've been working on this not quite a month yet, but it's getting close, and it should be getting close to start finalizing all the designs and start getting ready to do some test prints so I can get it, just to make sure that all my servos, the right socket, because there's tolerances, even though like if something is 30 millimeters and you're going to make a socket, you can't make it 30 millimeters. You should make it 31 millimeters for the socket because you need it to go in, and that's basically called tolerance. And when I'm designing these things and I print primarily with PLA, and eventually I'd like to print, something a little bit stronger. But like these tabs might be a thickness of 6 millimeters, which is okay, but I still like, I'll go 7 and maybe 10. But then there's other things that you have to calculate, and depending on the servo, is they have a grommet coming out of the side where the so-called servo arm is, and that grommet is like a little rubber gasket around the wire. You have these 3 wires that come out of it's 1 wire, but it's 3 wires that you got to make sure you have clearance on that post, because if you stretch out that post too far, you're going to bump into that wire and it's not going to work. But that's just that, foreseeing what you need to do. And when you do enough of them, you get where you don't want to mess up. And and that's why I keep designing and redesigning and keeping things in mirror. And plus, I want y'all to see what I do to produce this. And that way, when some of y'all are going to be true designers of what you want to create. And that's this whole goal of this channel, is that I want you to see what else that you can make with a printer, a 3D printer, instead of having something that's, making benchies. Now this creature that we're making is going to have 11 servos, and that's going to be 10 channels that we're going to be controlling. So 11 servos and 10 channels. Well, the reason why it's 10 channels, because 2 of the servos are going to be mirrored. So that means that two servos is going to be on 1 channel for the eyelids, and they're going to be mirrored with a Y cable and a servo reverser. Now, I just, like on this scaffold right here, I'm making adjustments right now so I can make sure that I can have my tool to get to the screw point or the nut to where I attach that servo to the servo socket. You'll see me sometimes on these videos how I'm studying what I've designed, and what I'm primarily doing is I'm lining up that servo to what that servo is supposed to be moving. And I can put the servo arm, I can put the linkage on the servo arm on the top or on the bottom. That way I can control it and have space to work with where I'm placing the servo socket. But here is what I'm concentrating on, is if I just do one side, I can mirror the other side, because I noticed I have another servo on that side, so I'll just cut this in half, and that way it'll be less work I have to do, and plus it'll be accurate. But I don't need that servo to be too close to the other servo, because I don't want those servo horns to be too close where they bump. And also, like I said earlier, that I can put that linkage either on one side or the other. It just all depends on what kind of room I have. You can see here how I'm lining it up, because what I'm lining up there is the servos that are going to be lifting the brow. I have two brows, that's those two servos we just replaced. And now I'm going to replace a servo on the bottom of the left one here, and that servo goes to the upper center lip. And to make it easier is I just highlighted this servo socket that I just made, and I duplicated it and flipped it, and that way I could just put it underneath there, and that is going to lift the so-called center lip. And I've been designing a lot of these animatronics where it's pretty much line of sight, to where, you know, the linkage is straight on to the servo horn. Now, if it's up or down, I can curve and rotate or angle that linkage arm to that so-called part that I'm trying to move. I just clean up this servo socket and get it right, and then I do a flip and just make any kind of adjustments that I need, and I can just drag the whole servo over there and fit it into the socket. But this one here, the other day I had designed a linkage arm to this servo to move that center lip, and now I can push that servo socket closer to that arm, as far as move it a little bit more to the right there, so it will line up a line of sight. You know, basically I just kind of laid a lot of the servos in there before on top or inside the other servo of the wing servo, and I just removed those servos after I get it designed, because I'm kind of like matching up the servo arm, because they're basically the same shape. They do have the same screw points, but these are just these are sub-micro, micro. Now you'll find out that some of the servo, once again, there's nano, there's sub-micro, there's micro, there's mini, there's standard, and then there's large, and then there's giant servos. And once again, there's thousands of them, and there's thousands of manufacturers. I'm saying thousands, but a lot of them are like rebranded servos. So the same, you'll see a lot of servos like that where it looks like the same one, but they got a different, you know, name or manufacturer name on it. But there's some servos that I just don't bother using. I mean, if you've seen the cheap servos where you can get 20 servos for, you know, $20, I don't even bother, because even just buy one and it either is too loud, or it's just not dependable, or it's no torque. And that's this thing. And don't get me wrong, there are some good cheap servos out there, but you know, when you're moving something, you know, you got to really study the torque, and like, and I do a lot of tests, and I test some of these cheaper servos just to see if what they could handle. And it's just like that little creature that I made, even though, I mean, it was a small creature and had 3 servos in the head. Those servos had enough torque to move that thin skin, and this skin's also going to be thin, and I'm sure enough it's going to move it, because the torque on these, I mean, it's they're really good servos, and I've been using these servos that I'm putting in here for about, I guess, four years, I believe it was. But you know, replacing the servo on the jaw, and this is where I'm getting where I have to make adjustments to this servo, because the wing servos are 6 millimeters thickness. These servos are 12 millimeter thickness, so you're looking at double the thickness. But they'll still work, and you know, it's going to be hidden behind the jaw. So it shouldn't have any kind of interference, but it's primarily there. That one servo there that's on that jaw is there to move the lower lip. But you see here, I'm going to have to make adjustments to the so-called servo socket because I'm only able to move it 30 degrees as opening. But when I had the, you know, 6 millimeters thickness of the other wing servo, I had more room. But you're not going to be able to. I mean, there's only a certain amount of openness that you'll have on a jaw anyway. But I can make adjustments so we can get at least 40 degrees. And being in the design stage right now, I could change the jaw by lowering it down some, but I would have to make adjustments to the teeth. But and that would be another design of the teeth. But I have them on file that I can just manipulate those to fit that socket. Now this upper center lip, this is the fork lip, you know, I have to add this piece right here, and I still need to make adjustments though. But because I'm using the same axis to rotate the center lip and this fork lip, so what I had to do is I needed to connect the two, but I had to make a crossover beam. That way it will have the two as one. But I need to still make adjustments though, because even though that this is up and give it clearance, if the fork is down, the center lip is up, you don't want it to bump into that support or that so-called beam. But here now, I'm added that tab there, that linkage tab to that fork. And I just need to make sure that it lines up to that servo to where it's going to be on the bottom panel right here. I have two more wing servos to replace, but also I'm moving this jaw to make sure it has clearance, not only bumping into those servos, but I need to make sure it's not going to be bumping into any linkages either. But here you can see where I'm moving that. This is the center lip. And with these servos now are being thicker and bigger, I really don't have a whole lot more room to put others. Now, don't get me wrong, there's going to be other animatronics we're going to design, and we're going to load them up with a bunch of other servos in it. But if we have small servos, we can have a lot more space to work with. But once again, to have that lower lip move also is a big key of having something realistic movements. And I had to make the servo being direct working mechanically on the lip instead of using a guitar string or a cable push-pull method. It just it's more subject to fail, my opinion, and it's better to have a hard linkage going directly to it. And the only way to achieve that is you have to mount the servo onto the jaw itself. It won't mechanically work that way if it's not on the servo. If you had it off the servo, it would have a conflict with the jaw servo. And so when the power's on, the servo arm is locked because it's in a lock position until it's commanded to move. But I wanted to show y'all this process. I wanted to show y'all all the whole process. I know some of this, I know some of y'all just maybe like printing, and some of y'all like designing. It's just I want y'all to see the whole process. And even though that, like I said earlier, that I might have been working on this a month, but a lot of this stuff has come from my previous designs. And to go through a whole setup, which we will do in a future animatronic build to where I go through the whole process from start to finish, and that's from a sphere to the eyelids and so on and so forth. And like eyelids, there's two different kind of eyelids. You got a blink mech, and then you have a floating eye mech eyelid, to where you have eyelids designed where they have uh, countersink holes in there where there's no straight through rod going through the sphere and the so-called eyelids. There's that method too that I'm willing to share my knowledge that I've accumulated on doing all this, and I learned from it, and I learned from my mistakes too. And trust me, you will make mistakes, and you try not to. No one does. I've had a person ask me a question today. One of the subscribers had said, should he get ZBrush? Hey, ZBrush is a great tool, and they have subscriptions where you can, it's a cost factor there. And this channel here, I'm trying to do it as low cost as possible. And there's a lot of great softwares out there, and some are free and some are really expensive. Trust me. I mean, there's software I'd really like to have. But, once again, it's a learning curve for every software. But Blender is free, and it does pretty much everything. But there's pros and cons to every software, and there's some that is really good on measurements, and when I say measurements, the only reason why it got me I guess obsessed with SketchUp is I like the measurement tool. And when you're designing these animatronics, I love how the metric works. And I could tell you probably uh, 4 years ago, I was doing everything in Imperial, and and I kind of learned that metric is when you're designing anything, it really needs to be in metric. We all have the passion for animatronics, and I really enjoy animatronics and love designing them. But there's like two types. There's the kind that you design from something, like you're working outside in. And this creature that we're doing here is inside out. So it's kind of reverse engineering. But I designed like several Grogu's, and a lot of people had certain measurements that they thought it was, and nobody really knows, but except the original designer. But as you see here, I made a lot of them. But it was a challenge and fun and a learning experience. And after a certain amount of time, you get kind of tired of doing Grogu's. But as you see here, I I had to get a part from it, and it was the magnet part, the socket, so I could put it on the alien creature that we're doing now. But this is what I would send to the people that would purchase my files. A kind of instructional video on how to put this Grogu together, and a lot of these parts have disappeared. And as far as Servo City had parts, and they were pretty much Imperial, and now they're going all metric, and some of their metric parts won't fit it. So I'm going to have to be redesigning this and probably put it up on the Patreon, and that will probably be later on. But I just wanted to show you this process, what I went through on designing some of this Grogu stuff. But it was a experience. But I would send this instructional video and some pictures just to help them put this thing together, and they would experience the world of animatronics. Centering a servo, power on, it will automatically center. And then what I do is this is a servo horn that we're going to use, and then what I'll do is I'll just snip off this end of this arm right here, and then I'll line it up to where it needs to be.
This is connected in the ear servos, which is the 225 Mighty Mites. This is a Y cable. Y cable is where you connect one normal and then you add a servo reverser. That way you can mirror the servos, as you see here. Here is the linkage for the eyelids. As it's connected to the eyelid controller, and it's kind of a loose fit. It's still tight with the nylon nuts. This is the metal servo arm, or the disc. I never could find the right thread. It was 902.5, so I just went and drilled them out and put M3s, and then I'll just place it on here, and then so I can mirror it to the other side, and this has the Y cable with one of them having the reverser. Hello, this is Gary Willett. I'm going to show you how to put this thing together. And this is all some of the hardware and some printed pieces. You'll have a few. There is going to be some, like with the ear servos, I'll send you some other parts to it as far as the ones that's going to have like real skin on it. Because the long pieces of the ears are just mainly just for looks. You won't use them in actual skin because they won't tolerate it. It's not strong enough. Well, and the upper lid and lower lid, as far as the roof, will have magnets and one will have pegs. But this is the main unit. This has all main servos and controls. And the eyelids this can be kind of fun to do and can be kind of tedious because there's really not a whole lot of room in there, but I have made smaller. But you just put them in there one set at a time. Then you kind of like open the eyelids after you get them all set with the flathead screws. And these screws are 440 screws. And on the outside, and maybe on the inside too, you could probably use the so-called nylon nuts. And but once again, I just open these eyelids up, and this is the closest I can really get to show a quicker way without the messy bench. And these eyes here have a standoff, and this rod here is a 6/32 thread rod, and you just have that 6/32 standoff, slide it in place, and it can be a tight fit. And if it's a little loose because the tolerance is really, really close, you can just drop a little super glue or a little epoxy on there and keep it in place. But you just pretty much thread it on through, and then you tighten your pressure nut, and then you put on the put on a nylon nut on the end if you prefer it. I just don't want it to back out, especially if it has skin on it. You really got to be pretty much, it's going to be a set deal. Excuse me. But just finding the tools to get it in the small space. But it's really fun. You can probably put this whole thing together in a couple of hours. But as you see here, the distance between the eyelid and the eyeball, it can get pretty close. Now the linkage here for these little ball joints. Now for the upper lid, these ball joints need to be cut. And this rod on these is the 256 rod. And I cut about maybe 4 millimeters off of it. You'll still have plenty of room to thread it in there. And then you just kind of remove it. And you can do it, I didn't do it with mine. I'll show y'all a picture. But it works out good. I mean, it's making linkage to make it work and be more reliable. Now, the eyelid control mechanism is here, and you'll have a rod that will go through, and its main rod is a 440 rod thread. And you might be able to find a screw that length, but it's just not. I couldn't find them at even a local hardware. I know they have 3-inch, but I mean, you could probably make it. But you know, you're so in my designing, everything is metric. It needs to be in designing. But once again, you just put that rod on there, and you'll seal this off with the nylon nuts, and then uh, you make sure your upper is first in the thread, and the lower lid is on top of the upper lid. And then you put these nylon nuts on, and don't tighten them up against the ball joints. Just make them tight on the rod itself, and leave it loose. You can, touch a little bit, but not put a bind on them. Here is the linkage for the eyelids, as it's connected to the eyelid controller, and it's kind of a loose fit. It's still tight with the nylon nuts. And then as far as setting the servo up, I put this little clock on there just to show you. It's basically at like a 5 o'clock position, but you need to turn the servo on first, make sure the servo's center, and then you put your arm in there. And then that stop link, that's the little brass fitting that's on the servo arm. That's gonna it will thread that 256 rod to the linkage, and it will be tightened down to hold that in place. Sometimes them holes are not small or large enough for the 256, and you can just drill them out with a drill. Just make sure you remove your screw, and then drill it out, and it'll screw back in place to give a tighter fit on that 256 rod. Now, the screws that I have on the servos, on these lower servos, are 440 screws, and you just bolt them down. And then as far as you center this mouth servo, and it's at more of a 430 position, and then once again you power up the servo, making sure it's center, and then you set your servo arm. And it's basically the same way you did the eyelid servo, but you have them opposite from one another. And then you put the mouth, and the mouth also has a 440 support rod or hinge mechanism rod. And then these parts here, I'll send you these parts. These are the newer parts I made just the other day, because I've been working on the core, and they were coming out of the core skin. But these are 440, and that connects to the linkage for the so-called gimbal. And this is the gimbal mechanism. This is the main support of the skull that holds and supported by the gimbal. And these little hubs, and these are 256. No, I'm sorry. These are 6/32 screws that holds, and this is from Servo City. And they've made some recent changes to the size of these U-joints. They used to be like 9 millimeters in diameter, but now they done changed it on me. But that's what y'all have ordered. You just tighten that down. You sandwich. It's pretty common just to make sure nothing bumps into each other, but this is the tightest that I could get it. But and these screws here, once again, are 440 screws, and you'll thread the larger ones down, and the other ones up, and you can probably use the nylon screws. All right, we're going to put the servos. These are 225 servos. These are what they call a Mighty Might. They should support skin. There are smaller servos, but they're 70, 80, probably around $70 a piece. These little holes on the side are for the grommets. They kind of want to bunch up against the inside of the skull. Just make sure you test your servo, make sure the center, you'd have to put a Y cable and a reverser on there, and make sure they mirror each other. Now, these servo horns are from China, and I never could find a thread. I think they're M2.5, but they wouldn't work, so I ground them out drilled them out and put M3 screws to attach the ear print part, and I just put them in place and tested, and as you see, it works great. And once again, you'll have these servos connected. You'll have 3 channels. You'll have a mouth, eyelids, and then the ears. And the ears have a Y cable with a reverser, and that works. And then as far as the gimbal, you have main part of the gimbal is the Servo City. That's the servo block. It'll be sandwiched with a 3D print, as you see here, to a hub, and the hub is connected to with 6 30-second screws, and you just screw them down. Connect that first before you put in the servos, and the servos will just be bolted in. I'd prefer little bolt screws, probably 6 30-second. And then your main rod, I told you to order. It just slides down. That rod needs to be cut to 100 millimeters, and it slides all the way down. And it will be a stop. And you just connect it to the U-joint, and these have a ball joint on the servo arm. But if you can't find the ball joint, you'll have to use the so-called ball links, as you see here at the top. This rod here is a 440 rod. These a little bit more support, and you'll just connect it to the servo arm and connect it to those little 3D parts right there, and it works great. Just thread it with a 440 screw, and then these ear parts are just mainly for looks. I don't believe they would support skin, but I'm in the process of designing that part for the people that are wanting to put skin on, and I'll send those parts to you. They'll have a place for a rod that you can put in there, and then you put this lid on. This is the one with the pegs, and it'll just pop in place, and it works like a charm.
Well, I just wanted to show you that, instructional video on how I got the Grogu, up and running. But as you see the size comparison to the one we're working on here now, and I designed the Grogu probably a year and a half, maybe 2 years ago. But as you see here, like in that nose area, the 2 nuts, the space that I had to design it, being so close together, I mean, it was a challenge because, once again, it was something that was pre-existing, and I had to make something inside of that so-called measurement that we were all coming up with. But, and I'm designing the alien, or this so-called 3D printed creature that we're doing, and once again, it has to be according to a certain size, but that's the size of the build platform of the large resin printer. But I mean, and plus, on top of that, is that the Grogu has 6 channels, and the creature that we're making is going to have 10 channels, and we're going to have a lot more realistic movements. But you see the nuts there on that Grogu where the nose is. But I mean, that was a tight fit, but I have made tighter. But I just wanted to show you this and show you the size comparison, and just show you other animatronics and these eyes right here are floating because they're countersunk screws in the eyelids, and those eyes are floating straight ahead. Even though that the eyes are tilted at an angle, they're still aiming straight. So, but in these eyes on the creature we're making, they are beads. So that's a lot more easier for us to do, just having control eyelids like this, than having like the Grogu. But once again, I had to get a Grogu part in the skull lid. The skull piece had a magnet that I put to attach the skull to the other part of the skull, and it had a measurement. And since it's part of my library, I can go in there and just copy that socket, and I can move it to the side. And now, when we make the skull lid to the creature that we're making, I can use that same socket, and so we can insert uh, neodymium magnets in there so we can get it just to snap on and snap off. We'd like to thank everyone again. Thank you for the comments and the thumbs up and the shares. And y'all keep sharing and keep pressing that thumbs up. It helps the channel grow. And I appreciate y'all. But y'all have a good day. Later.